JUnit Advanced Annotations. Lecture 4. Advanced Test Annotations. JUnit provides two ways of testing: basic testing and advanced testing. In basic testing, you make a test class and you test your methods with test methods. In advanced testing, you have the option to configure the JUnit runtime on a per test class or per test basis, with annotations to behave differently and in more complex ways than when using the basic testing strategy. Advanced here does not imply difficult, just more ways to test, which is needed only when your testing needs go beyond the basics. To be a JUnit master, you must learn this advanced stuff and you must retain it for your day-to-day use. This is where you will shine in your job and you can become an indispensable part of your team. So I encourage you, for the sake of these good things, to pay as close attention to this part of the course as you did in the first 3 lectures. For basic testing, the first 3 lectures are fine, but to be a virtuoso testing master, you must master all the lectures. So don't let your attention slip one single bit, and be ready to put some more time and effort in getting real good. From now on, the material is going to keep getting more interesting as we are getting into the real deal on JUnit now. Do you want your test to run multiple times, each with a different data item passed in? This sort of a run could be simulated from within a test method, but JUnit provides a way with annotations that is cleaner and leaves you more focused on testing the business logic, rather than setting up the test from within the test method. The annotation we are exploring is called Parameterized Test, and I am going to make a 10-second pause for you to write it out. In the case of using this annotation, the test method can contain arguments that will be passed into the test method with each invocation in the order they are listed in the following type of annotation. So an additional annotation called addValueSource annotation will then provide the list of values to be used in order with each run of the test method. And I'm going to make a 10-second pause for you to write out addValueSource. The addValueSource annotation takes the following types of data: short, byte, int, long, float, double, char, boolean, string, class. Additional add-something source annotations are available, which get data from different places: addValueSource, addNullSource, addEmptySource, addNull and empty source, addEnumSource, addMethodSource, addCSVSource, addCSVFileSource, addArgumentSource. We will explore them in code in the lab that follows this lecture, and now I am going to make about a 60-second pause for you to write out all the source annotations. When you need to pass a large number of arguments into a test method, it is cleaner to use the argument accessor object as the only parameter into the method, and to get that large number of parameters you want to supply from that object, not from method signature. Usage examples for the add parameterized test annotation follow. I'm going to make about a minute pause for you to study this code. You don't have to write it down if you don't want. Let us go on. If you need the same method to be run multiple times, you can use the add repeated test annotation. And I am going to make a 10-second pause for you to write out add repeated test. This annotation has two attributes, value and name, where value can be omitted if used alone. And so I'm going to make about a 20-second pause for you to study the next bullet, the next line of code. You don't have to write it out if you don't want. The values in curly brackets are optional placeholder arguments, the name of the test, the current repetition of the test, and the number of total repetitions specified in value parameter. In this case, 20. Repeated test.long display name and repeated test.short display name are the two built-in strings with placeholders. The first has all three, while the second omits display name. And I'm going to make a 30-second pause for you to write down these variables. So, and thank you, by the way, for bearing with me for asking you to write them out, because what happens is you cannot possibly retain all the data from watching the course and even taking the quizzes and doing the labs in 1 week. You will forget a lot of it, but if you write it out, you will retain much more than if you don't. So if you wanted to fashion your own message string, or if you needed these values programmatically for whatever reason, you could supply the repetition info class as a parameter to the methods annotated with add before each, or add after each, or as a parameter to the add repeated test method itself, such as add repeated test void test method repetition info ellipsis. And I'm going to make a 15-second pause for you to write down the last bolded line. Because Java Virtual Machine typically warms up and hotspots code, repeated tests can be useful in figuring out how fast your code eventually will run, but it also has other uses. To rehash, we have covered two advanced unit testing annotations in the previous several slides. These annotations are, and I'm going to make 10-second pause for you to write them out again. They're very important. Add Parameterized Test, add Repeated Test, the Add Parameterized Test annotation basically allows you to run the same test with different pieces of data depending on the additional add something source annotation you supply. For example, the add value source annotation or the add enum source annotation, etc. The add repeated test annotation allows you to run the same test more than once. For example, to see how long it takes to run after Java virtual machine warms the code up, or for other reasons. The next annotation we will explore is called Add Test Method Order. And this annotation controls what order our unit tests run in. Generally, you do not need this annotation because your unit tests should not depend on the order in which they run under general conditions. However, if you need to ensure that your unit tests follow in ordering, this annotation must be used to make sure they do. This annotation is applied at the class level, not at the method level. This annotation may be used for complex testing scenarios involving integration testing or functional testing, where a multi-method invocation needs to be verified as correctly performing. And so I'm gonna make a 15-second pause and ask you to write out Add Test Method Order at this time. Alright, let us continue. This is how we can use this annotation. We must provide this annotation with our implementation of the method orderer class. We can also use one of the following built-in classes: alphanumeric, order annotation, and random, where the seed for the random is either supplied by the runtime or is supplied by you in the JUnit configuration file. Or we can roll a totally custom orderer. For example, add test method order, order annotation.class, public class tests, add test, add order 1, void, test method, ellipsis. And I'm going to make a 30-second pause for you to write it out. Alright, let us continue. You can configure the random seed for the random method orderer in the JUnit-platform.properties file by adding the following line: JUnit.jupyter.execution.order.random.seed equals value, where value is an integer. And I'm going to make a 15-second pause for you to write out this line. Please use number 1 for value. You can also roll your own custom orderer by implementing the method orderer interface directly. This way you have complete control over the ordering of your tests. Another annotation of interest is the add test instance annotation. To ensure cleanly running unit tests, the default behavior of the JUnit runtime is to instantiate the test class anew for each test method. This way you get a fresh set of your instance variables for each test method, but not your static variables, obviously. The code within the add_before_all and add_after_all annotated classes is run only once in all cases because the methods are static. If you want to maintain state across unit test invocations, you can direct the JUnit runtime to do so by annotating the test class as follows. And obviously when I say maintain state, I mean maintain instance variable state. Add test instance lifecycle.perClass, whereas lifecycle.perMethod is the default. And so I would like you to write out two lines. Add test instance lifecycle.perClass and add test instance lifecycle.perMethod. This is a very important annotation, and I'm gonna give you 30 seconds to do it. In this case, add test instance lifecycle.perClass, the runtime will reuse the same class for all its unit test invocations. Whatever changes, resets, etc. to instance variables you wish to do, you will have to do it manually, if they are needed. The default behavior of the JUnit runtime, of course, is to instantiate a new instance of the test class for each test method invocation. That is the default behavior. It does not have to be specifically provided to the runtime as an annotation. If you have more than one test class, you can control this behavior on the per class basis according to your testing requirements. Now on to another annotation. The add timeout annotation specifies that the method annotated with it should fail within the specified period of time. Obviously a very, very useful annotation. Now I'm gonna make a 10-second pause and please write out add timeout. Several time units are supported, such as days, hours, minutes, seconds, milliseconds, microseconds, and nanoseconds if the Java virtual machine supports it. For example, and please write it out as I'm going to make a 15-second pause. Add timeout value equals 100, unit equals time unit dot milliseconds. Within the JUnit-platform.properties file, many sensible default values are provided for different types of methods this annotation can be applied to. The property strings specifying these defaults begin with JUnit.jupyter.execution.timeout.star. Obviously, star is the value of a default. So please, I'm gonna take about 10 seconds for you to write it out. And you can look up the JUnit-platform.properties file for examples. The add timeout annotation can be applied to the following types of methods: add test, add test factory, add test template, add before all, add after all, add before each, and add after each annotated methods. Currently, this annotation is still in the experimental stage, but it won't be so for long, so probably as you are traversing this course, it is already in full production mode. Let us rehash the 3 annotations we have covered since the last rehash slide, which are, and after I speak them out, I'm gonna take 30 seconds for you to write them out again. Add test method order, add test instance, add timeout. And I'm gonna take a 30-second timeout. The add test method order annotation is applied to a test class and controls the ordering of the unit tests within a test class, and is useful for complex testing scenarios such as integration or functional testing. The add test instance annotation is a class-level annotation which controls the life cycle of the test class, whether it is instantiated anew for each test method or whether it is instantiated only once at the onset of running all the test methods within the test class. And finally, the add timeout annotation can be applied to different types of methods within the JUnit runtime, not only those annotated with add test. This annotation makes the method fail when the specified time interval is exceeded. These annotations obviously are not needed for plain vanilla testing scenarios, but only for more complex testing scenarios. So, more advanced annotation will follow yet. Do not relax your intellectual curiosity, because there is much more to come. This lecture is rather long, and we have reached about 40% mark of it. So if you would like to pause the course for 10-15 minutes, go stretch your muscles and then come back. So let us continue to the next slide. We are going to cover 2 annotations next, which are quite complex and which you need to learn and to apply quite thoroughly in order to gain advanced status as a JUnit practitioner. These annotations are add test factory and add test template. These annotations will empower you to write your unit tests in a very advanced and efficient manner. Good luck! Please invest the time to fully understand these annotations and how they can make your unit testing into a bona fide powerhouse. So, we are about halfway into the course, and at this point you already have the ability to bring your reputation as a software engineer to a new level due to your good mastery of basic and intermediate JUnit concepts. What follows is the material that, once mastered, will give you the reputation of possessing advanced unit testing skills. The add test factory annotation provides you with the ability to create dynamic tests. There are multiple ways in which dynamic tests can be created in JUnit, but all such factory methods producing dynamic tests must be annotated with the add test factory annotation. And I'm going to take about 10 seconds for you to write out add test factory. You must memorize a little bit of the add test factory API, I'm afraid, in order to get proficient. Let us do so on the next slide. The test factory method annotated with add test factory annotation must return the following set of return objects: a single dynamic node object, a stream, collection, iterable or iterator of dynamic node instances, an array of dynamic node instances. And so I'm going to make a 30-second pause for you to write all of those things out. For example, dynamic node, stream type dynamic node, collection type dynamic node, iterable type dynamic node, iterator type dynamic node array. Let us go. The dynamic node class is abstract and cannot be directly instantiated. Instead, it has two concrete subclasses called dynamic container and dynamic test. And I'm going to take a 15-second pause for you to write them both out. So dynamic container, dynamic test. These, pardon the typo, these subclasses allow us to write multiple sets of dynamic classes if needed, to place them into dynamic containers, and to iterate through them as needed. So it is a new and quite flexible testing model, new in JUnit Jupyter 5. Add test factory methods cannot be private or static. Add before each and add after each annotated methods run only once for every add test factory annotated methods, regardless of how many dynamic tests it produces. This means that any instance fields you modify in the process of running a dynamic test will not be reset at the end of the dynamic test. They will be reset at the end of all the dynamic tests produced by your method, however. Let us look at some code examples of dynamic tests in the next couple of slides. If the test factory method annotated with add test factory does not return a valid return type, the JUnit exception will be thrown at runtime when this error is detected. Some examples of the add test factory usage follow. Please pay attention to the use of the executable functional interface as part of the usage API. To refresh your memory on the executable interface, you can check out Lecture 1 slides 12 and 13. So let's get started with some code examples. So add test factory list type string, void test factory, return arrays as list incorrect return type. This will cause the JUnit exception to be thrown at runtime because, list type string is the return type, because list type string is not a permitted return type. Now let's see some correct use cases for this annotation in code. First, we must import the static methods which makes this possible. And please write it out after I have spoken this. Import static org JUnit Jupyter API dynamic container method dynamic container. And I'm gonna give you 15 seconds for it. Import static org.JUnit.Jupyter.API.dynamic test. And I'm gonna give you 15 seconds to write it out. So next is a snippet of code where we create a collection of dynamic test instances and return it for the JUnit runtime to run them. And I'm going to give you about 45 seconds to study this snippet of code. Basically, what this snippet of code does, it returns exactly two dynamic tests out of the test factory method, and then what the JUnit runtime does, it takes them and it runs them in turn. So here you can see that we use the lambda syntax instead of implementing the executable interface as an anonymous interface, because lambda syntax excuse me, is cleaner. Well, let's see some more examples. Here you can see about three snippets of code that return various data structures acceptable to the add test factory interface. In the first case, it returns an iterable of dynamic test. In the second case, it returns an iterator of dynamic test. And in the third case, it returns an array of dynamic test. So please study these snippets of code for clues about how the add test factory annotation works. Okay, let us continue to the next slide. And this one basically returns a stream of type dynamic test, and I'm going to give you about 20 seconds to study this snippet of code. This stream-based return value is actually probably the most flexible of all. And so you can see that of all the 4 tests it produces, it will pass only once, where the length of the text is 4, which will be for the value true, and for the other 3 tests it will fail. And you can make 10,000 of these values if you want. So, and you will have created 10,000 unit tests. Well, for the previous code snippet, it tests 4 values, in effect generating 4 dynamic tests. You can also generate a random number of dynamic tests by using the stream return type. The code is extensive but extremely useful, so you can find it on the next page. It's kind of involved, so I'm going to give you a couple of minutes to study it. Alright, let us continue. And finally, we're going to see the last example of the add_test_factory annotated method, where the return type is just a plain dynamic node. You can also create dynamic tests and place them into a dynamic container with a unique name, such as the following: add test factory, dynamic node test factory, return dynamic container, etc., etc. And I'm gonna give you 30 seconds to study this snippet of code. Okay, let us continue. Now that we have spent quite a bit of time on the add_test_factory annotation, let us take a look at the add_test_template annotation, quite an advanced topic within JUnit. Needless to say, both add_parameterized test and add_repeated_test annotations are special cases of the add_test_template annotation, which itself must be used with the add_extend_with annotation featuring the test template invocation context provider interface implementation. This implementation will tell the JUnit runtime how to run test cases that are annotated with the add_test_template annotation. So I am going, I'm going to make a 30-second pause for you to write out add_test_template, add_extend_with, and the mouthful test template invocation context provider. This implementation will tell the JUnit runtime how to run test cases that are annotated with the add_test_template annotation again. So if you wanted to run a test method with different parameters, or repeatedly, or by preparing the test class instance in different ways, or multiply without modifying the context, then this advanced annotation is the way to go. And we will see more of this advanced annotation in our lab, because it is hard to explain, but fairly easy to see in action. This is a good time to rehash the two annotations we have covered in the previous several slides. The add_test_factory annotation allows you to prepare a battery of dynamic on-the-fly or otherwise non-static unit tests by using a well-defined dynamic node and its subclasses dynamic test, dynamic container, class hierarchy. It is a good way to generate unit tests in a very flexible manner. In addition, it provides several means of obtaining unit test data from different sources that can be used by build tools and IDEs. We have omitted this functionality, but you can check it out by reading the JUnit 5 official documentation. The add_test_template annotation is an annotation which is used in modifying the semantics of how a unit test is run, for example by making it repeated or parameterized. So I'm going to make a 20-second pause for you to write out again add_test_factory and add_test_template. And pardon my coughing a little bit of a throat issue related to lack of water over long talking distances. So much better. So let us go forward. In fact, both add-parameterized test and add-repeated test types of unit tests are programmed by the JUnit runtime by using the add-test-template annotation. The add-test-template annotation is always used in conjunction with the test-template invocation context provider interface implementation, and the add-extend with annotation that specifies this implementation as its parameter. Unless your testing needs are truly complex, you are not likely to need the add-test-template annotation in your testing code. However, it is on the lab and it is on the quiz. There is an annotation which allows you to further federate your unit tests within a test class, a very useful annotation, the add-nested annotation. And I'm going to make a 10-second pause for you to write out add-nested. A good use of the add-nested annotation is to test various aspects of what is being tested more clearly by grouping related tests into an inner class annotated with this annotation. For example, you might want to test the empty state of an abstract data structure and the state with only one item in the abstract data structure and the state with more than one item in the ADT, or the state when the ADT is full. And the most clear way to go about it is to group it into all these unit tests into an inner class annotated with the add-nested annotation. And you can have many add-nested annotations and with inner classes within one test class, if you like. The add-nested annotation is a code beautification annotation for more testing clarity. Other uses can be thought out, but usually it is better to keep things as simple as possible. And other uses involve different life cycles for different inner classes. The add before all and add after all annotations do not work in inner classes because they require static methods not permitted in inner classes. So if you annotate static methods for your add before all and after all annotations, then you cannot use them with the nested annotation. However, if the add nested inner class is annotated with add test instance lifecycle dot per class, then this limitation is circumvented because in this case, the above annotations do not have to be applied to static methods and can be applied to instance methods. The add nested annotation is also useful if you want to vary the test class lifecycle within the test parent class for whatever reason, as I mentioned before. But it is better to use as simple testing semantics as you can though. So let us go to another annotation. The add display name generation annotation allows you to create custom test names. It is useful to provide running commentary to unit test execution. If you use both add display name generation annotation and the add display name annotation, the latter takes precedence over the former, so do not use them together. Add display name generation annotation takes class object of the display name generator class. For example, display name generator dot replace underscores dot class. And so I'm going to make a 30-second pause for you to write out add display name generation, add display name, and display name generator. Okay, let us go. The JUnit.Jupyter.displayName.generator.default parameter in the JUnit-platform.properties file controls the default test name generator class applied by configuration. it takes a fully qualified class name. And I'm going to make a 10-second pause for you to write out the JUnit.Jupyter.DisplayName.Generator.Default. You should in general get your hands on a copy of the JUnit-platform.properties file and to thoroughly look through it. It will do you a world of good. Let us now move to the annotation that enables us to filter through unit tests and to run unit tests in filtered sets. The add-tag annotation takes a string parameter that denotes the category of the unit test it is applied to. This annotation can be applied to a test class or a test method, and multiple add-tag annotations can be applied to the same test class or test method. For example, add test, add tag dev, void, unit test, method body. And I think I'm missing a void there. So I'm gonna take a 15-second pause for you to write this line out. Okay, let us go. It is possible to filter unit tests based on a add tag value and to run those unit tests only. This is accomplished by using the add include tags and add exclude tags annotations applicable to test suites, which are subject of Lecture 7. An early example follows, using JUnit Runner, however, because test suites are part of the JUnit 4 platform but not part of JUnit 5 platform. However, they are retained still within the JUnit 5 Jupyter platform for use with the IDEs that do not fully support the new JUnit 5 semantics yet. So please study this code for about 30 seconds. Alright, let us continue. Let's now rehash the three annotations we have covered since the last rehash. Those annotations are add nested, add display name generation, and add tag. And I'm gonna make a 30-second pause for you to write them out. So we deliberately group seemingly unrelated annotations into these rehash sessions in order to deepen your JUnit understanding across the entire framework all at the same time, thus moving you forward on all fronts, so keep your attention sharp. The add nested annotation allows you to group unit tests into logically related groups within the main test class. The add display name generation annotation allows you to provide running commentary to a unit test's execution, not just vanilla info but some more complex info, maybe with hints of what results are or are not expected. These are visible in the output of unit tests having completed. And the add tag annotation groups unit tests across and within test classes into logical groups that can be run together as a unit. This annotation is useful when you are creating test suites, which are covered in Lecture 7. There are a few more advanced annotations we will mention without going into them in depth. The add tempdir annotation, the add extend with annotation, and the add register extension annotation. and I am going to take 30-second pause for you to write out these three. The add_temp_dir annotation can annotate a method parameter of type path, or file, or an instance field of same types. It provides a temporary directory if a unit test or a test class needs it. As of now, it is still an experimental annotation, but you can use it freely. add_extend_with is used together with add_test_template annotation in order to provide customized ways of running types of unit tests. This annotation also registers a JUnit extension declaratively, but that is subject of a later lecture. And finally, the add_register extension annotation is applied to a field within the test class, and that will register a JUnit extension programmatically, which is another way to register a JUnit extension. It is otherwise equivalent in function to the add_extend_with annotation, and these are features specifically of the JUnit 5 Jupyter platform. So we are completing our advanced test annotations lecture 4, so let's go on to the last slide for the conclusion part, or rather last two slides. Great job, but keep your attention sharp. We have reviewed 22 annotations which can be considered to be advanced JUnit annotations. Using these annotations expands what we can do with JUnit and unit testing considerably, and some require in-depth immersion even past this course, such as the ones dealing with JUnit extensibility. By now, you have learned enough to become an intermediate practitioner of JUnit. More advanced topics are to follow. So finally, please keep in mind, the simpler the setup that meets your requirements, the better it is in the short and long term for your project and for your team in general. At this juncture, I think you are starting to realize how exciting it is to properly test your code and to properly maintain high code coverage for your code. Great job. And great job, you have basically just given this lecture over 50 minutes of your attention. It is the longest lecture in the course. I won't torture you this badly in the future, I promise. So now let us get started on the quiz 4 and lab 4. Great job and good luck.